Hello students, let's move on to the next section of this chapter, gravitation, that is the concept of satellites. And in this very module, we'll understand how are these satellites launched. But before I start with the launching of satellite, let's understand the fundamentals of what exactly is a satellite. How do we define a satellite? You know, there are many satellites which are moving around the earth for communication purposes, for the meteorological department, for defense and so on. So how do you define it? A basic definition of a satellite would be something like this. It's an object which is revolving in an orbit around the planet due to its gravitational force is called as a satellite. For example, if I consider a moon is a satellite of Earth, so it's revolving in an orbit around the fixed planet Earth due to the gravitational field of the Earth, and that's the Earth's satellite, which is moon. So I hope you are clear. A satellite is a revolving object around a planet under the influence of its gravitational force or gravitational field. Now, on broad spectrum, satellites can be classified into two kinds. One is a natural satellite, like moon is a satellite of Earth. Are we a satellite? Are we a satellite? Of course, we are revolving around the sun. So we are the satellite to sun. Okay? Just like moon is Earth's satellite, right? Earth is a satellite for sun. So that's natural satellite. There is one more, artificial satellite, right? The man-made human satellites which we forcefully put in orbits around the earth for our personal uses. So basically an example would be the INSAT-1B, which is a purely Indian artificial satellite which is used for understanding the climatical conditions. Right? Now, let's understand how these artificial satellites are set into orbits. To understand this, let's understand first the trajectory of the satellite launch. When you consider Earth and its gravitational field, a satellite is launched with the help of a rocket launcher. A rocket launcher which provides the necessary energy to put it in that right orbit so that it can revolve around the earth with a constant speed. So basically that rocket launcher, or we call it as simply a satellite launcher, is propelled or pushed very high up inside the gravitational field. Now it is not directly put into the horizontal or circular orbit. It's initially taken to a very high height and then brought back inside the gravitational field to that particular orbit in which it is to be revolving. With the help of multi-stage rockets providing the necessary horizontal velocity, vertical velocity, a small adjustment here, there, finally the orbit is set and the satellite is put into its trajectory. That's a circular orbit around the earth. It could be an equatorial plane or it could be in the polar plane. These are the major planes in which the satellites are launched. Now, to understand a very elementary way of how satellites are launched, we need to fundamentally divide this velocity with which it is projected into two components. A horizontal component and a vertical component. A vertical component to go to that certain height, horizontal component to push it into some kind of a circular orbit. Okay, so ideally we'll try to understand this, but practically both the components are given together. It's a projectile trajectory velocity with which it is moved into a circular orbit, and then the launcher ceases and the satellite opens up and it starts moving in that orbit for years and years to come. Okay, so in this case, let's understand this in a very elementary manner. Let's consider the gravitational field and understand how do we launch an artificial satellite. Now the fundamental question is, can we launch a satellite with a single stage or a single rocket? successfully into the orbit. When I say single stage means providing only the vertical velocity. Think over. If I give only vertical velocity. If I give only vertical velocity, there would be two situations. Either suppose if the vertical velocity is too much and the rocket just moves out of the gravitational field, then it will never come back. It's gone. Pata nahi kidhar gaya. Right? But if the vertical velocity is something less than what is required to move out of the gravitational field, what will happen? After the field finishes, naturally the gravitational pull will start pulling that rocket down and the satellite will finally fall back on the surface of the earth. Right? So only giving the vertical velocity, is it sufficient? I don't think so. Right? Either it will move out of the gravitational field or it will go to that height and stay there, but the gravitational pull will start pulling it back and it will come down. So what they say is, for launching a rocket we require at least two stages. Okay, that's the first one would be to give the necessary vertical velocity. So the first stage gives the necessary vertical velocity to go to that certain height, and the second stage of the rocket provides the necessary horizontal velocity so that the satellite can start moving in a perfect circular orbit around the earth. In this case, please understand, if you just give the vertical velocity, it's not sufficient. It's also to be given a certain horizontal velocity. Understand? Here we've just broken the trajectory velocity into two components. In this, students, the second component, horizontal component of that velocity, is most critical, because if that horizontal velocity is little less or little more, it breaks out of the orbit. Either it goes outwards, goes into some kind of abnormal elliptical paths, or if it is less, then it moves spirally inside and falls back to the surface of the earth. So the more critical is that horizontal velocity, remember, which we'll be discussing in the next module also.